we've got already the model. Let's check it how it look like. Here we've got the weights, and so we've got weights for 76 parameters with 6 classes. Here we've got the prediction image. Let's work with let's test it, how it works. To test it, I know here we've got some, 1 second, in repository we've got some testing data. This actually is for images from the differential InSAR. These are geotypes. Let's cut it. Let's go with small image. I know in one of them the jump it's actually somewhere between 200, 2100 from left, from upper also 2100 to 2400. There is no value. Okay, let's set up the settings. Import image. Projects, repository, data, testing data. This is in the last image. So this is the image. It's much higher than, it's much bigger than the learning data. It's 300 by 300. So this is basically 90,000 pixels, and we can clearly see that there is the jump here that affects actually the recognition of the deformation between this part and this part. And we can see clearly here that on histogram that there are 2 high peaks of the value. So let's try it, how it works. To prepare for the model to test it, we need to also stack this image. Let's do it. With the bigger image is go a little bit slower, but still not too bad. This program is working on the typical laptop, so if we are using if we have the more computational power, it will work much faster. We need to use parameterization. More. Okay, and parameterization is done. We have to set this data as a testing data. So here is the option testing data. It will be the second model. The current model is the second model. Here we can apply the weights created in the first model, estimated in the first model, and we can apply them to the second model. So the current model is the second one, and the weights, the training data parameters are in the first model. If we check it, here the testing data is activated. The set is the fourth one. We don't require here the class data because it will actually predict from those weights. It will predict how it works. We've got 80,000 pixels. This is because of the cutting from the mask size. Let's check it. Ballistic. Oh yeah. Here in each process, if we forget something, it will show us what we forget about. So for example, here I forget about to standardize those data. And to do it, because of this testing data, we just go to X testing data, X testing data, standardization. It's going very fast. So data. Here we can see standardized data. Now we can just go with the probabilistic images. Let's view it. Okay, so what we've got here, as we saw on the image, there was the very clear edge of the jump from the one part to the second one. So on the edge of this image, the model predicts that there are many artifacts there, which are probably the cause of the jump. Then the next classes, they are actually false because of the value of the pixels. So that's why here we don't see any deformations which are actually there. Maybe not big, like less than 5 millimeters, but here if we check it, like this part, it's deformation here from 10 millimeters to 20. Actually they are less because of this jump. But let's predict the image. Let's check it how the class is here. Yes, as we saw, there is the jump. That's why the classes here and here are different. To work on with this problem, we can easily do this by here we've got the options, jump, remove. Let's go with fast mode. Fast mode, the difference between those modes are that the full mode is not cutting another pixels from the image. It's going a bit slower because of there is different algorithm to do this. However, let's go with fast mode, and it will cut a little bit of pixels from the edge. However, it will not affect the final view of the results. How is this algorithm works? It's actually it's taking the whole histogram of this of the first image which we were which I imported here, and we saw it. There are two peaks. What this algorithm is doing, it's actually finding the where are the it's like cutting this this histogram between each peak. We've got the minimum and the maximum of that. On minimum, the algorithm is cutting the population of the pixels, and it's creating a first class and the second class from the histogram, and then it's actually checking for each pixel to which class it should go. and it is working on the whole area of, if I remember good, it's 30 pixels, 30 by 30, which is quite many. Like here we've got the range is 50, so we've got like this part of the image. It's checking to which class it should go. Here we've got the results. Here we've got exactly histogram how it works. So we've got the two classes, and this is the barrier, and this is the maximum of this class. On that, basic on that, it's checking to which class the pixel it should go, and here we've got the full result that there is no jump between this part and this part. The only thing is that this whole area, there are still artifacts. We cannot change the value of this part basic on jump removing, because of there is no information to which part it should go. This is just artifacts. However, let's check it. This image, how is on the new histogram? Oh, we can see it here. That for now the histogram, it looks much better. There's no second peak here, and the mean value here it's around 1.5 millimeters. Now we can actually check it to which class is this part. This is actually higher than 0, so it should be non-deformation here, but let's check it. Let's stack this data. Parameterize. Okay. Let's set this data again as a testing data. It's a third one. Or let's apply it. The weights. Okay. This time I will not forget about the standardization. Let's go here. No, let's check it. Okay. Now we still can see that there is this one big line with the artifacts, which were recognized good as artifacts, but then we don't see. Here we've got actually the part of the non-deformations, but here we've got the part of the deformations which are from 0 to 5 millimeters. But let's predict this image, how it works. Okay, so we don't have the 0 class, the first class. We actually have only the second class and the third one. yes, as we can see, the jump was removed from the image. What we can do now, we can select the image which was done by the jump removing. View it. And we can simply export this image. Export it. Go here, export image. Here we've got the whole image which was exported. We can import this image again. However, what we can do as well, we can just simply save this image. Here we've got a few options. We can just use TIFF file. Yep, let's save it. And this is the actual image. Alright, that was actually I've got one more option to show at the beginning of this program. We don't have to learn this process each time to work with the new images. What we can actually do, we can just export the model. Let's do it with the first one. Where we see it here is the export. It's a model data. I exported before some model, but here are the full model with weights, with classes. We've got everything here. If we want to now work again, start again, let's type it. Py. You can just simply import this model. You have to pick this file. Data import is done, and here we can see it, the whole model. So that was it for the beginning. In next part I will explain more of the settings. We've got plenty of settings here about the learning process, about the parameters which we can work on. What this is basically, if we want to get fun with this, if we want to just simply remove the jumps, we can just very easily and quick work on with the process which I show you. So yeah, that's it. Thank you.